Hi, this is Dr. Frederick, and so there was a question about how to work some of these problems in Module 7. And what they are the bounding problems that you've been working on in graphing, and it's just not clear that that's what they are. So, here we have a problem. It says if we have 114 pounds or kilograms of chocolate-covered nuts, and we have 72 kilograms of chocolate-covered raisins. We have a mix in which we can mix these things equally and get $7. Or we can mix 3 times the amount of nuts to raisins and sell it for $9.50. And so these, these are the limits. If we put X and X here, we have equal amounts of the first mix, and then here we see that we have 3 times the amount of a mix in the, of the ratios in the second mix. So we're just going to say that if we use X plus 3Y, we'll get 114. We have 100. What you would say is X plus 3Y is less than or equal to 114, right? The maximum amount you can use is 114 pounds. So you're going to have a value of X plus 3Y that is less than or equal to 114. It's going to maximize at 114, right? If you can use all these values, all these kilograms, that's where you're going to make your most money. And so here we have X plus Y equals 72. So, if you take the 3 equations, which would include, if you were graphing X greater than or equal to 0, Y greater than or equal to 0, I just solved it quickly by hand, by substitution. So X plus 3Y equals 114. X plus Y equals 72. So here we see that Y is equal to 72 minus X, which I substituted in the first equation. So just simple algebra. Now we'll just multiply this out. X minus 3X plus 3 times 72 is 216 equals 114. So that's negative 2x equals negative 102, or 2x equals 1, or 2x equals 51. So we go back in, and we're going to have 51 and 51 kilograms in the first mix. So let's look up here. That's all right. So then, what is y? Well, x plus y equals 72. So here, y is 21, right? Y is 21. And 3 times y is 63. So we used up all of our combinations. We ended up with 102 kilograms of the first mix, 84 kilograms of the second mix. At $7 per kilogram, that's $714. At $9.50 per kilogram, that's $798. Add them together, get $1,512. That's the maximum revenue you can get, and you're going to use up all your product. Okay. Now the next problem, number 3, should work very similarly to this, but the idea is to set up these bounding equations and then solve in whatever way that you find it easiest to solve.